Alright, hey guys, we're going to go over exact differential equations. So determine whether the equation is exact. If it is, solve it. So let's just look at this equation here. Okay. This is a differential equation, and that's what we're trying to do, is solve differential equations. It's not separable, it's not homogeneous, but it's something else that we haven't talked about. It's exact. So what does that mean? Basically, we're looking for a function whose partial, some function of xy, whose partial with respect to x is equal to, this is conventionally termed, this coefficient function here is conventionally termed m. And this by convention is just that which is associated with the dy is termed n. M, function m of x and y, function n of x and y right here. So if you take some function and you take the derivative of a function of x, y, and you take the derivative with respect to x, you will get this m x y. Likewise, if you take this same function, if they're exact, and you take the derivative of that with respect to y, you will get n xy. So we're trying to find this mysterious function. Now, to solve this, you have to make sure they're exact. So if they're exact, if function m of xy is the derivative of this function with respect to x, and if I were to do a double derivative with respect to x and then with respect to y, I should have the same thing if I did, this is y. If I did the same thing here, but with respect to x. Because this, or in other words, you could say the derivative of m with respect to y. Because m is already this. It's the partial derivative of f of x and y with respect to x. So basically, if we take the double derivative, xy, which equals this, we should get, well, let's figure out what that is. So let's take, because dx has already been evaluated here, so let's take dy. So let's integrate this with respect to y. Any y terms in there? What's the derivative of 2x? If x represents a constant, it's 0. Okay. Now that should be the same if we take this, which is the derivative of the function with respect to y, and we differentiate it with respect to x. What would we get? We get, there's no x term here, there's no x term here. We get 0. So we know that equals the derivative of nxy, mxy, with respect to x. It's kind of difficult to understand. You're going to have to read about it and basically maybe rewatch this video. I mean, that's just how it is. I don't know how to explain it any other way. That's just how it is. So now let's go through the mechanics of actually solving the equation. Okay, so how do we solve it? Well, we're trying to find this function xy. So if we were to integrate this with respect to x, because remember, this is the function xy with the partial derivative with respect to x. So if we were to integrate the x, we would get this function back in a sense. It would have so this is confusing, but it would, let's integrate this, let's go ahead and do that. So we got 2x minus 1, and we want back this x that we had differentiated out, because we want this function. So this is what we're looking at here. This is x squared, right, minus x, because the 2 goes in the denominator and wipes out this 2. So you see that, right? So, but you're going to have plus gy, which is all of the y terms that got eliminated when you differentiated this function with respect to x. Because when you differentiate with respect to x, you treat the y's as constant. So we lost them because they were just 0. Does that make sense? So here's our representative function g of y. It's our representative function of g of y. Now we have this function. This is the presumed function that we're looking for of xy. However, we got this gy here. So let's take the derivative with respect to y. So let's take the derivative of x squared minus x plus gy with respect to what? Gy. And this will equal our nxy, which is right here. So we'll be able to compare the derivative of this sort of generalized, it's not really a generalized, but it is in g of y, function with respect to y. So let's do that. What's the derivative of this with respect to y? 0. What's the derivative of this with respect to y? 0. What's the derivative of this? Well, it's the generic g prime y. So we have 0, 0 plus g prime y. That is supposed to equal this up here, 3y plus 7. So g prime y equals 3y plus 7. Right here. Now, what do we need to do? We need to integrate that dy. Integrate that dy to get our function back. And this is going to be our function. So, go ahead and integrate that. You're going to get gy equals 3y squared over 2 plus 7y. So let's run out of space here. So we have our gy. Then what's this? I should actually use this right here. We have our gy. So what is this? This is our f of x, y, which we're trying to find. But we didn't know the gy, but we got the g prime y, we integrated it, and so now we got the gy, so we can put it all together here, x squared minus x plus 3y squared over 2 plus 7y. And that's our answer. So to sort of recap quickly, which is hard to do, basically you want to make sure that this criteria is met, that the partial of m with respect to y gives you the complete derivative of the function, which should equal this with respect to x. So, did I say that right? This is already the differential of the function with respect to x. So derive it y out of it, and this the opposite, because it's the opposite. All right.